Okay, I guess we can start? No, or maybe not.
Just a second.
Just a second, all right.
Sure. Congratulations on the widening project.
Thank you so much. You saw what happened?
What happened? You got it.
We got the money.
Yeah,
You see that happen?
of course.
Okay, thank you all for being here today. Today is not simply another comparative politics seminar series, it's a special event, it's a CIVICA event. And we're extremely happy to have with us today both Melissa Sanz from LSE and Alrababah from Bocconi. And I'm very happy to have both of you. Melissa is going to provide, is going to present a paper for us, and then Ala is going to discuss. Before we start, however, let me tell you first of all that given that this is a CIVICA event, some things have to implications follow. So the first one is that this is going to be fully recorded and published on CIVICA website afterwards. This is very important for some of us. You know how the dynamics of the seminar go, so that you know whatever happens here is not going to stay here anymore. It's going to go online and will follow you forever. That's the first thing. And the second thing is, and the second thing is that that I have to say something about CIVICA. So what is CIVICA? CIVICA is a underfunded, severely underfunded, amazing initiative, which is essentially a consortium of universities from Europe, especially departments of or faculties of political science and social sciences from Europe, and it is already moving to a step where it's becoming consolidated. It has started to include also new members beyond the set of universities that were that initiated the project. The UI has been from the beginning one of those universities. LSE was from the beginning as Bocconi members. Of course, Brexit has generated some obstacles in how this relationship can be continued, but it is being continued, and we're extremely happy to have, for example, Melissa and others from British institutions with us. I guess that's all I can say for now about the CIVICA. It's really a fantastic initiative. Many of you have already benefited from this by organizing seminars following lectures which are way more advanced and interesting than our lectures in 100 universities online and vice versa. So this is, I think, a very nice initiative and conjecture, and one that will generate, I think, a very interesting synergies in the short and the long run. Okay, without further ado, then I'll give the floor to Melissa for the presentation. We're extremely happy to have you again. And then after Melissa's presentation, we'll have Alla presenting some, discussing the paper. Thank you.
All right. Thank you so much for that introduction, and thank you to CIVICA for not kicking us out when Brexit happened. All right, so the work that I'm going to be presenting today, this is joint work with Paige Ballin, who is an assistant professor at Ohio State University, and Joe Higton, who's a PhD student at NYU. And this is part of a much bigger project, as I'll allude to. This is sort of the beginning of a bigger project. So just, I guess, have that in mind as I go forward. All right, so we've all had this experience of walking or driving through a neighborhood and sort of taking cues from what we see. Right? We might think something about the relative wealth of an area or the safety of an area. So actually, let's start with a thought exercise. This is the interactive component of the beginning of the talk. So let's say we're visitors to this city, or even prospective home buyers. Does this seem like a safe area to you? So if you were asked to rate on a scale from 1, meaning extremely unsafe, to 10, extremely safe, what would you give it? You can just shout it out. Okay, it was a 5 over there. I heard someone else say there was a 4 over there. Okay. Okay, so you are in line with the average American. It turns out if you ask a randomly selected American how safe they think this neighborhood is after dark on a scale of 1 to 10. Oh, sorry, actually you are much more, I guess I don't know, braver, or you believe this is much safer. So the average American, sorry, I misread my notes. They give it about a 2.5 out of 10 on average. So that's sorry? Oh, sorry. Yeah.
Because you didn't ask us after dark. So
I didn't say after
maybe
dark.
if you said after dark, we will be
Okay,
more.
let's back up. Okay, forget everything I said. All right. No, but notable that you thought of that, right? The safety of a too many things. Okay. I wasn't warned. No, that wasn't a dig. Right. So your perception of the safety of a neighborhood might depend on whether you're considering walking through it during the day or at night. Okay, so if I were to ask at night, 1 extremely unsafe to 10 extremely safe. Some answers. 1, 2. Thank you. 2.5. Yes. This is all the information that you get. It's hard to take a picture at night, so.
I don't see it here, so perhaps it will buy some.
But it's what you see. You have to infer.
2.5.
All right. So if you ask the average American, they say 2.5, very unsafe. Right? If you ask the average resident of this city, which happens to be Detroit in Michigan, they say about a 4 out of 10. So they see it as safer, but that actually masks some heterogeneity by gender. So if you ask women, they give it a 2 out of 10. And if you ask men, they give it a 7 out of 10, men in Detroit, right? I will note that, well, if you ask a GPT, right, if you ask a generative AI tool, they give it a 4 out of 10 on average. So this is a preview of what we do in this in this project. So in case you are going to fall asleep for the rest of the talk, let me just briefly tell you what we're doing and what our goal is here. So our goal is to analyze how human perceptions of street view images compare with the assessments of a generative AI tool. And we're particularly interested in the subjective perceptions of sort of national respondents versus local respondents, the respondents of people who actually live in these places. Now, generative AI, as you all know, is being used for a ton of things, right? It's being used, including as a shortcut to understand public opinion. So one of the things we want to ask in this project is, whose perceptions do generative AI tools reflect? So our approach is to take something that we see as inherently subjective, images of neighborhoods, and ask a national sample and a local sample for assessments of three basic characteristics: disorder, safety, and wealth. We're going to ask the same questions of a GPT, focusing first on OpenAI's most recent tools. So we're using the API that the interface that you're probably most familiar with is ChatGPT, but we use the GPT API. And we're going to compare the responses. And so far, our findings suggest that GPT's evaluations somewhat track human survey takers' perceptions, but national perceptions are better represented than local ones by these tools. And so as I noted before, this is the first stage in a project in which our intent is to model subjective perceptions at scale. So we want to incorporate local demographics and connect these perceptions to political outcomes like voter turnout and voting on relevant public policies. But before we do that, we want to understand whose attitudes these tools reflect, and indeed, if they reflect the perceptions of the people who actually live in these places, which we argue are the most relevant for public policy. All right, so some background, right? We are, of course, not the first to study what neighborhoods look like and how this might matter for people's experiences. So systematic social observation was pioneered by a group of sociologists led by Robert Sampson and colleagues. And this is basically a standardized approach to assessing various attributes of neighborhoods. And this project, which originated in Chicago in the 1990s, involved researchers driving around Chicago in a van with a camera mounted on top and taking pictures or video as they went around the city. And then those images are later coded for a whole bunch of variables related to things like land use, physical disorder, building quality, even things like abandoned cars or graffiti or drug paraphernalia on the ground and so on. And then there's a body of work that uses this Chicago data set to study the link between physical disorder and outcomes like health, civic engagement, and political participation. I see a hand, yes.
So how are you planning to use the GPT data, the assessments, in order to study electoral outcomes and preferences regarding, I don't know, redistribution or other policies in general?
So, so our intent. So our intent when we started down this road was to look at correlations between attributes of neighborhoods and variables like turnout and voting on relevant policies like there's some like blight mitigation policies in Detroit. If you were asking me about a research design, can I
vote based on their personal perceptions, be it right or wrong? So I guess that locals have a perception about their neighborhood, the area that they live in, and then they make certain decisions, be it on, party preferences or other stuff. And I just couldn't understand how you are planning to use GPT or whatever, like AI generated assessments in order to understand how locals vote or.
Oh, yeah, sorry.
Do
So-
you prompt them locally? Do you prompt GPT to?
Yeah. So the idea is that we can't ask everybody their subjective perceptions, right? There's no possible way that we can do that. In fact, most of the time when we're interested in context effects, when researchers are interested in context effects, they use objective measures like racial demographics or inequality, right? But ultimately, what matters is how people perceive those things, right? The idea was that if these generative AI tools can do a good job of representing people's subjective perceptions, then we can basically train a generative AI tool. We can train a model on, a random sample of assessments, and then use that to scale up, essentially, right?
The point is to save money.
The point would be, yes, so it would be a lot cheaper for sure. I don't know that it would even be possible to actually do this without doing some sort of extrapolation, because you'd have to ask. But yes, like given limited resources, we would need to model this. Yes.
So basically this is validation, right?
The step that I'm going to talk about today is mostly a validation exercise. Yes.
But like how can you do it overall data? Because ChatGPT in particular, I think if they reveal another model will be a different thing.
Yes. So we are replicating this with other. We are replicating this with other models as well. When we started this project, this was the only publicly available tool that could take in images along with text prompts. So we literally used the only tool that there was. We've been working on this for about a year now, and now there are other tools. But you're right. Okay. Okay, so this is a body of work that uses the Chicago data, study lots of outcomes. Then along comes Google Street View. Fantastic. Now we don't have to worry about only looking at Chicago or only looking at this particular set of images. We have Street View images from all over the world. And indeed, researchers have used this data to study things like political participation and gentrification. Google Street View has this really great feature now where you can look over time and see how a neighborhood changes over time, which is super valuable. So we can study things like gentrification. But all good things must come to an end. And like anyone who's worked with, say, social media data over the past few years and has watched companies clamp down on access and make it more and more difficult for people to access things, Google Street View changed their terms of service within the past couple of years, and they said explicitly, don't use this for any academic research purposes. In fact, they even said, don't even download our images and save them on your local machine, right? You might be thinking, well, terms of service aren't legally binding. Why don't you just go ahead and use Google Street View and, ask for forgiveness rather than permission? That would be delightful, and I would love to do that. But increasingly, journals are asking researchers for evidence that they have permission to use this data. This has happened to me with other work where we were using a public data set, and the journal, before they would publish, wanted explicit permission from the government agency in this case, right? Google is saying you can't do this. These restrictions apply. So we turn to a non-proprietary alternative called Mapillary. Mapillary is just a crowdsourced version of Google Street View. This is a map of their coverage. Their coverage is getting better all of the time, but it is not anywhere near what Google Street View is like. there are billions of images that have been uploaded by users, but mapillary is dependent on the kindness of quirky individuals who like to mount cameras on their cars and drive around cities and take pictures. No shade to you if you're one of those people, more power to you. So the images are very similar to what you would see on Google Street View, but the coverage is much less complete. And I'll talk a bit about kind of how we approach that. Finally, we're speaking to a very, very quickly growing body of work on generative AI as a research tool. We see our work as sort of blending two kind of nascent strands of research in this area. One is this burgeoning body of research that uses LLMs for classification and other measurement tasks, doing things like extracting topics and sentiments and other features of language in context. Our focus is on images rather than text, but we similarly leverage these feature extraction capabilities to categorize relevant information. The other body of work that we are speaking to is that on silicon sampling or synthetic samples, right? This is work in which an LLM is used to generate a synthetic population of respondents, conditioning on the actual demographic profiles of survey respondents, and then used to simulate actual human survey responses. Now there is a growing body of work, and I think this is probably where we're going to end up fitting in, at least for this initial part of the project, a growing body of work on the critiques of this approach. Right, but our work is related to this in that we impute synthetic evaluations that mimic subjective evaluations provided by humans. The work on synthetic sampling and silicon sampling exclusively focuses on text applications at the moment, but we think it's really not much of a leap to image applications. So we imagine various city planning applications. Let's say the city of Detroit or another city decides that it's very expensive to survey a whole bunch of residents, so we're going to use generative AI tools to try to figure out, how best to allocate resources to neighborhoods or something like this, right? Or get a sense of the safety of the neighborhood so that we can allocate, police resources or so on, or something like that, right? There's actually already work coming out of marketing and computer science that uses generative AI tools with vision to assess different packaging designs. Right, so here's an example from the marketing world where generative AI tools are being asked to look at images of items and provide subjective assessments. Right, so this is sort of the vein that we think we are working in. Okay, so the first thing that we need to do is identify cities to focus on. We start with one city, and that is Detroit. These other cities, Houston, Washington, D.C., Miami, Amsterdam, and Brussels, all have really good mapillary coverage, or at least they did about a year ago when we first embarked on this. And we start by focusing on a really small sample of 85 street view images, because we really want to understand the relationship between what's in these images and what people think of them and what generative AI tools have to say about them. So this is before we scale up. So our first step is to pre-process or crop the images. We then query the GPT 30 times each. Each question image pair is asked 30 times. This is just to get a distribution of responses for each question and image. Then we survey humans. We have a national quota sample, a national US quota sample, and a Detroit probability sample. And then we're going to compare these. We're also going to compare subgroups and bring in some objective data as well, which I'll get to. So basically how this works is we have our map of all the scraped images. We have our map of Detroit. We basically navigate the streets and select and grab or scrape the images along those paths. And we do this for all of the images in Detroit. That gives us a sample of 85 images. throughout the city of Detroit that we're going to focus on. Now, unlike Google Street View, which, Google does this nice job of sort of processing the images and making them look friendly. This is what the 360-degree mapillary images look like. When you go to the website, you can see they're a bit distorted. So we take some steps to make them look a little better. Going forward, actually, we're applying a defishing algorithm that's going to make it less like you're in a fishbowl. But for now, we basically do some cropping of the images to make them look more normal. We use GPT-4o to collect assessments. Our API allows us to do this at scale. And as I said before, each image question pair is asked as a separate request. So there's no memory of previous images or questions. And we do this 30 times. Yes. Oh, yeah.
During daytime and in similar weather conditions?
Thank you. So unlike Google Street View, there is some variation in the atmospheric conditions. Right now, we're just kind of treating that as noise. We looked at all of the images in our sample of 85, and none of them had, weather features that were particularly egregious. I think actually mapillary, there may be some quality control, but.
Picture, and then I realized that the thing that I like the most is that it's a very sunny, yes, and not the house. But it took me like 10 seconds, 5 seconds to realize.
But it shouldn't matter because GPT versus you look at the difference between GPT and human intelligence.
Yeah, so we're looking within image at this moment, so that shouldn't matter for those comparisons. But you're right that going forward, if we compared between images, that could matter. Yes.
Yeah, so I was wondering, do you ask the ChatGPT to respond as a citizen of the given city, or do you let it guess how it should respond? Because that might be the explanation. But this is one part. The other part that I was going to ask is like, so I understand that you are presenting us here with a two-phase process, no? So in one phase, I see it. You want to basically to check whether we can use ChatGPT instead of going to the people. Makes sense, no? But the ultimate goal of this is to use it for the to predict some political behaviors or whatever socially relevant behaviors. But there, I'm not sure. So I don't know to which degree do you want to engage in that part in this presentation or generally. But so there, I'm wondering, what are we actually interested in? Are we interested about the objective, because apparently you're not collecting the objective conditions of a given locality, but instead the human perception thereof, which will then depend on the variability of the reference point that these people have. For me, the first picture, apparently also for Elias, was 7 safe. I mean, seems nice, no? So, but also if this is, so people might be thinking that they are having it good and still suffering from having it bad. So then do you have like a theoretical prediction where you want to go in with this, or is it still, like that you are focusing on the first phase of the process?
So today I'm just going to present the first phase of the project, but I can respond to both of those questions. So to the first question, we do both, and I'll show you the results in a moment. To the second question, I can sort of also say we do both in the sense that we do also look at objective conditions, which I'll show you in a moment. So ultimately, what we find is that the GPT does not do a very good job of reflecting these local attitudes, right? So that brings into question our the sort of plan that we had at the very beginning, which was to connect the local attitudes to local behaviors. It may just turn out that this is not the right tool for that. I think we are interested in subjective perceptions in their own right. So we are interested in the idea that living in a particular place is going to change your perceptions of that place. And also the relationship between subjective perceptions and objective conditions. So yeah, I mean, I guess this is, you know, when you set out to have when you lay out your project and you say, I'm going to use a generative AI tool to do this thing, and then you think, oh, maybe I should test it first, and then you test it, and it turns out actually this tool is really bad for this thing, and then you write a paper about it. That's sort of that's the process. Yes.
So maybe you will address this aspect later, but when it comes to perception of the local environment, people are used to their environment. What matters for them is the change within the neighborhood. They're more likely to react to change. If I live in a neighborhood like such as the first picture you presented, I'm used to it, and I will probably just not change my vote because of the setting. I will change my vote if it's like improve the neighborhood, then probably I will reward the incumbent or whatever. So do you take into account like change in the specific setting, or?
So we would love to be able to take into account change. Mapillary hasn't been around as long as Google Street View. They have in the last several months introduced an over time feature, but there are typically not photos over time there. But what that suggests, I think, is that that's the direction they're going in. So hopefully we will get to look at change at some point. But this actually makes me realize that there was another part to your question that I wanted to respond to, and I didn't. And that was about, sorry, can you remind me what?
I also don't know.
Okay.
I also don't know which part exactly you mean. I'm sorry. So I was asking like whether you prompt the ChatGPT, and also whether you have, you know, so in a most simplified word, like the place is either safe or not safe. And I believe that it is safe or not safe.
Oh.
So do you have, you know, 2x2 predictions on what's going to happen?
I see. No, yes, I dodged that question, and because I don't, and I'm going to continue to dodge it. But what I thought was also embedded in your question was that the first image you see is going to set the baseline for the subsequent images. And so I was just going to say that for our Detroit sample, they only see one image. And for our US sample, they see 3 images, but we tested this. We looked for, I guess, primacy effects, and there was no difference. So people aren't.
Okay, by reference point, I really meant what else I saw in my life, not necessarily in this.
Okay. But absolutely, this, I agree with you that what you see in your life is going to affect how you answer these questions, and that's probably part of what's going on. Okay, so let me just finish with this part by saying that we are aware of this of kind of growing concerns about the replicability and transparency of using these generative AI models. This Barry, Palmer, and Sperling is a really good piece on this topic. If you're interested, I would suggest reading that working paper. But we try to implement some of the best practices that they suggest. So we are replicating this with, currently replicating it with Gemini. We'll probably do another tool as well in the future. And we're also running our models multiple times over multiple months. So we collected a bunch of data in August, the end of August. And then just before this talk, we collected this, we did it again. We asked all the questions, each question image pair 30 times of the GPT, and got very, very similar results actually. And we're going to keep doing that so we can sort of document over time if there is change. Okay, so what were the questions that we asked? I sort of bungled how I asked you all this in the beginning, but we asked on a scale of 1 to 10, how safe would you feel walking around this neighborhood during daylight hours? And then we asked the same thing about after dark. We also asked, how wealthy do you think the people in this neighborhood are? Also, we actually also ask a question about income, but the scale of the responses is very different, and people really struggle with that answer, even though we tell them the average income in that area. So in this today, I'm going to just focus on the questions that we asked that have this 1 to 10 scale for ease of comparability. We also asked a question about disorder. We developed the wording of this question is a bit long. We developed this in conjunction with the survey researchers who run the survey in Detroit, who were worried that our original wording, which was much shorter, would confuse people. So this was the wording we ended up using. For our Detroit sample, so we partner with the Detroit metro area's community studies at the University of Michigan. This is a panel study that's been running since 2016. And importantly, this study is designed to capture the diverse perspectives of Detroit residents with an emphasis on reaching the hardest to reach populations. So Detroit is a city that it's a very interesting city that has gone through a lot of change over the years, but it's a very low income city. It is majority Black or African American, and a lot of the and this is a population that is often difficult to reach with surveys. So we partner with sort of the experts on reaching this population, and I think this becomes important later, which is why I flag it. And then we use Prolific to implement a nationally representative survey. Respondents also ask a series of background questions about themselves. We haven't yet used this data in our analyses at all, but we would like to at some point, although we use the gender question. I guess that's the one that we use so far. And then for each image, respondents give their evaluations of the area's safety, disorder, and wealth. Okay, finally to the findings. How much time do I have? Plenty of time.
At this point, it doesn't matter. You just
Okay,
continue.
okay.
I mean,
Okay.
we definitely need to keep 15 minutes for your discussion,
Yeah, 10, 15.
but I'm sure we'll be fine.
Okay, great. I'm used to running out of time, so this is comforting. Okay, so to preview our findings, GPT-4o's evaluations seem to track human perceptions of disorder, safety, and wealth, but there are often big differences, and it depends on the way that we measure sort of concordance, and I'll present that to you in a moment. We find that the GPT's assessments align more closely with those of the national sample compared to the locally representative sample. We do employ tailored prompts. We try this both with tailored prompts, like you live in Detroit. We've tried imagine you were a resident of Detroit, a couple different versions of that. We settled on you live in Detroit and you are a woman who lives in Detroit, these sorts of things, a la silicon sampling or synthetic sampling. And these don't help. In fact, sometimes they make it even worse. We find that agreement between the GPT and labelers varies by question. Unsurprisingly, perhaps, generative AI tools perform worse for more subjective concepts like disorder than they do for perhaps more objective concepts like safety or wealth, although it's, we can argue about what is subjective and what is more subjective. And we do find that when it comes to the Detroit population, the GPT's assessments correlate much more strongly with those of Detroit women compared to those of Detroit men. Okay, so these look kind of small. Okay, I'm going to orient you on the plot. So along the horizontal axis is the ratings of humans, in this case, Americans. And along the vertical axis is the GPT's ratings, right? They both go from 1 to 10. And we have this separately for wealth, safety in the daytime, safety at night, and disorder. And then hopefully you can see the correlation coefficient on there. So this is just looking at our national sample versus the GPT's evaluations. And we see pretty strong correlations, actually. The line here, there's both a low S line and a linear regression line with confidence intervals, but they overlap pretty nicely, so it's hard to tell the difference. So we have correlations around 0.8, not too terrible. Now, when we do this for Detroit, we see the correlations get a lot weaker. So the strongest for wealth, we have 0.72. For safety in the day and at night, a little bit under 0.6. And then for disorder, it's really bad. It's 0.16. If we try to see if we can do better by telling the GPT, you live in Detroit, before asking these questions, we get like, don't do better. In some cases, maybe we do like a tiny bit better, but then in others we do worse. So this synthetic approach does not help us at all here. It really doesn't buy anything here. Okay, yes.
Just clarification. So one observation here is the average across respondents or ratings for one image.
Yes, thank you. I meant to say that. Yes, thank you. I meant to say that each point represents an image. Yeah.
What I understand from this is super interesting. Even the fact that you're not able to find anything, it does mimic national more. But the abundance of knowledge is more for national, and probably women in Detroit post more about these things in the internet than men because it's more unsafe perhaps to walk alone, and it's for them it's priority wise. So does this tell us that GPT is working with the abundance and it's unable to filter out? But you know what I mean? So Detroit woman versus man mimics woman. National versus local mimics national, because what is an abundance of, if you compare women and men, perhaps women post more. So GPT works with everything that's related to Detroit, tries to predict the next word, and gives us this. So what are you reading the results in a similar way? This is still interesting, but this, I'm following you perfect.
Yes. Yes. So I would agree with what you said, basically. It's perhaps not surprising that GPT does a better job of mimicking these, it's trained on national data, right? So it's perhaps not surprising that it reflects this more national attitudes. As I flagged before, Detroit residents and Detroit men in particular are a hard to reach population. That's why we worked with this special survey organization at the University of Michigan, which is actually located there and knows this population, has been doing this since 2016, right? So GPT is going to do a worse job at reflecting hard to reach populations. Like that's part of the takeaways here. I haven't shown the men and women results yet, so we'll get to that. And I think there are a few other takeaways, but yes, that's, I mean, things that seem maybe obvious in retrospect, but when you start the project, anyway. I hope that ultimately one of our contributions is going to be thinking carefully and hopefully coming up with good ways of showing the concordance between these responses, right? So what I'm showing here, the bottom panel is exactly what I showed you before. It's those correlation plots with the low S lines. On top is a plot of that reflects statistical significance, basically. So what we did here was for each image, we conducted a t-test of the difference between the GPT's assessment and the human assessment, the relevant human assessment. It's kind of like a light pink, the beige bars, the beige area of the bars represent the proportion of images for which the GPT and human assessments are not statistically different from each other. The darker brown represents where the GPT significantly overestimates relative to humans, and the sort of coral peachish color where it underestimates. We wanted a way of showing sort of where overestimations versus underestimations are happening, which are hard to see in the correlation plot, and also wanted some measure of the statistical significance of the difference here. Can I just say, we've experimented with various ways of presenting this. We did some tests of the like KS tests reflecting whether the distributions are different and so on. And I'd be interested to hear if people have thoughts on the best ways of presenting this. But ultimately, we thought these sort of pairwise comparisons made a lot of sense because the way that we're imagining researchers are going to be using images with these GPT tools is actually, showing a single image and it being interested in evaluations of images rather than a distribution of images. But I'm happy to be convinced otherwise. Yes, in the corner.
How respondents themselves agree on certain images? Maybe there's huge variance. It's just hard to reach, hard to interpret neighborhood. Maybe Detroit people are less. It just varies a lot for them.
It's okay. Sorry, I didn't catch the.
So I wonder how respondents themselves agree on evaluations of pictures.
With each other.
Yeah.
Yeah. So yes, like inter-rater reliability. Yes, we have looked at inter-rater reliability. I didn't actually include that in the presentation. We have looked at like the distribution of GPT answers because we have these 30 draws and the distribution of human answers. And the GPT's distribution, if I remember correctly, is tighter than the human responses. I'm sorry, I don't have those.
Yeah, just a small comment based on Denise's comment, actually, because now, okay, so, I mean, I have used ChatGPT to rate neighborhoods in Brooklyn very recently. And when I asked, okay, so how do you proceed? How do you proceed? For me, okay, what it told me is that I use actual statistics. So then there, it gave me a list of links from websites and, many different sources where there is statistical evidence on crime rate, for example. The police department, some NGOs. And this is data collected from humans again, right? So could it be that you just compare some information collected from some experts and then which is publicly available to what people, the average citizen or the average American or whatever believes about this place?
So, as I'll show in a moment, there's no correlation between actual crime rates and subjective ratings of safety. We can talk offline. I'd be curious to hear what you did. One of the things we've done is ask the GPT to explain, to give a justification, and it has never drawn on like actual statistics, although we haven't asked it to, but also, yeah. But we're also, keep in mind, we're looking at, it's like an image of it's a much, I would imagine that what we're doing is a much finer level of aggregation than what you are. Even crime data is not available at a geocoded level, right? It's snapped to the nearest intersection.
So 2 fingers on this. So you just showed an image. You didn't say, here's an image of Detroit.
We did not say it was Detroit, no.
Okay.
Yeah, we assume we assume that the Detroit residents know that it's Detroit. I think for them, we might have even said it's Detroit for the Detroit residents. We did not say. Yeah, we did. Yeah. Yes. Yeah.
We've been looking into doing something similar, but I was just wondering, have you at least this is what I've been thinking when we were working on it, if you have considered thinking about it as a classification problem, because then you get another way to express if you calculate an accuracy score with the humans as the reference category, then you get suddenly a whole other range of measures that can say something about what it's actually good at and what it's not good at, the way you would evaluate if you trained a model. It's just another way to think about the same problem. And we sort of got stuck, but I think that there's something to gain by thinking about it like that, because then you get to see where are the mistakes actually coming from? When is it good? When is it not good? If you take, yeah.
So this is maybe a more involved conversation, but we see ourselves. Okay, so another way to put this is like there is no ground truth here. Right, like it's not a classic classification problem in that sense. We actually see ourselves as operating between two paradigms, like between a survey paradigm and a labeling paradigm.
You can still think about all, like, it's the way that you operationalize the insecurity of a classifier. It's just a way to try to map where are the two measures not aligning. So whether you consider, like, whether it's two different truths, it would give you a more fine-grained measure of where they are not aligning and where they are in agreement. Whether it's two different realities, then we can see where they overlap.
I guess I see the point from a presentational perspective. I'm struggling to see where the additional information comes from,
I will think
but maybe it's a, yeah, yes.
Just a clarification question also on how to read this graph, right? So if I read correctly, there is an agreement in the final classification of GPT and of your coders, so of humans. Is the assumption, the implicit assumption here that they're informed by an identical bias? Or also to say, do we assume that the bias informing GPT's decision, and we know that GPT is biased on a number of dimensions, is the same of the respondents you interview? Or is there a problem for, I mean, so they get to the same result, but maybe out of completely different biases that led them to classify? Is there any way to test for this, or?
Thank you. So here we're just using a two-sample t-test. So that's going to assume that they're coming from two different populations potentially. I don't know if that. I mean, I'm not sure if what you're saying is an argument for.
Can I help this the conversation? I will have the conversation in two ways, I hope. One is to say that yours will be the last question, because then we will continue, because we need to allow time for Allah. The second way I will have the conversation is the following. I guess people are missing, but you have to understand that this is being missed because doesn't exist. This is the lost Atlantis of objectivity. There is no objective truth out there to tell us how subjectivity works. So whatever Melissa does, it will always be what we have done in our paper, which is comparing different measures who try to get to some truth that is unobservable. And that's where I think they are all trying to get in and say, look, but then you can do this, you can do that, you can do this. I guess Ricardo's point is this okay? Like, are you aiming for GPT capturing the human bias well, or are you aiming for GPT capturing subjectivity well? And I think you have no answer. And also because what's the difference in a way between the two? Kind of.
Yeah.
Or maybe there is a difference, and I am too not fine-grained enough. I know. But anyway, that is unresolved, I guess. Right? So yeah.
Yes.
Alex, sorry.
Yes, in short, it's related to subjectivity as well, but for among your humans respondents. So let's say that I live in Detroit, for instance, and I notice that my neighborhood is part of the images that you provide to respondents. So I will probably benchmark other images of other neighborhoods based on my evaluation of images from my neighborhood. So is it a problem depending on the distribution, I mean, the characteristics of respondents in your sample that you might bias their relative perception of other neighborhoods and the ratings of other neighborhoods? Is it a problem for you think, like the within sample? I don't know if it's, sorry.
So, I mean, I think this is just part of the nature of subjectivity, right? Like everybody is bringing their experiences to the table when they're evaluating these images. One thing we haven't done yet that we intend to do is we do have information for the people who live, the Detroit respondents, we actually know exactly where they live. And so we can see if there's a difference between, you know, how people respond if they live very close to and are likely to be very familiar with this neighborhood or not. We also have data on how long they've lived in Detroit. So these sorts of things can help us, I think, sort of get at this a little bit. But no, I don't see it as a problem. But it's definitely something to think about.
I just asked because during my dissertation, I was thinking about doing this with Montreal, and one of my co-supervisors saying that you can't really because people will just recognize the pictures within the sample and then probably be biased already and evaluate all the images based on their own situation. I mean, their own perception of the neighborhood, basically. So it would like introduce some biases within the, and then I dropped the project.
But it's like, if you, no, so that's fair, but like, imagine you're a prospective home buyer in a neighborhood or you're a prospective renter, like you're bringing your biases with you too. So
Just a quick one. A kind of a follow-up question here. Like, did you prompt that in the last one, you live in Detroit prompt? Did you also say that the image is from Detroit as well, so that the GPT can gather data related to Detroit, so that evaluates how secure, how wealthy, how something, something?
I don't remember. I don't remember. I can check. I'm not sure if we did or not. I will say that when we first started this, we asked GPT to guess what city the images were from, and it was very good at guessing that it was Detroit. So it may be the case that it just knows that it's Detroit. Okay. Okay. So we break up the findings. We break up the responses by gender. We see again relatively strong correlation between, this is American women, this is not the Detroit sample. These pretty strong correlations. When we say to the GPT, you are a woman, basically no improvement. It does a lot worse for Detroit women. And again, that's not helped by, actually, when we tell the when we prompt the GPT with you are a woman, we get like a slight improvement. But not when we say you're a woman and you live in Detroit. It only works for you are a woman. Here, I think interestingly, we almost see more of the time in these pairwise comparisons, there's a non-significant difference, but there's still this systematic underestimation and overestimation by question, and it's not always predictable which way it's going to go. When we do this for men, again, it does all right for American men, but when we get to Detroit men, things completely fall apart. So so for wealth, the performance is the best. The correlation is 0.6. For safety, it's 0.3, 0.2, and then disorder, basically 0 correlation. And again, this has not helped even the relationship even becomes negative. Correlation becomes negative for disorder. And we've already talked about reasons why this might be the case. This is, again, those are similar. Okay, I've already previewed this. Do ratings reflect objective conditions? I'm not going to present all of the plots all of the relationships that we made, but let me just tell you what we do. So we look at 2 different data sources. One is blight violations. These are violations that are issued by the city of Detroit for things like, they can be for graffiti, they can be for being out of compliance, they can be for failure to maintain a vacant building or structure. Right? This is an official record of blight, of disorder. We think it's a pretty direct measure of disorder. And usefully, these are available at the address level. We have the actual addresses for these blight violations. And then we also take data on major crime incidents as recorded by police, but these are available at the nearest intersection level. So we have to come up with a way of actually using these 2 spatial data sets, right, that don't perfectly overlap. We try a bunch of different things, but what I'm going to show you today is, so for blight violations, we take 1 year of the blight violations data and we create a 50-meter buffer around the coordinate point for the image, and then we just count the number of blight violations within that 50-meter radius. We chose 50 meters based on some playing around with like what we thought would be, what we thought felt like close to that neighborhood. Okay. For crime incidents, we have to go a little further out because crime incidents are snapped to the nearest intersection. So if our radius is 50 meters, then we often don't cover any intersection at all, and those places would just mechanically have zero crime. So we do the same exercise with the radius at a 100-meter and a 200-meter buffer. Doesn't make a difference which we do. Just show you some of these. So along the horizontal axis is the count of crimes within 100 meters. Plotted on the y-axis is the mean rating of safety at night by for the 3 different samples, and there's no relationship here, right? Same for 200 meters, no relationship. We do the same sort of exercise with blight violations and disorder, no relationship. Blight violations and subjective wealth, no relationship. So do ratings reflect objective conditions? No, they don't seem to, at least not as measured in this way. Or blight, yes, or blight violations. But I would argue that crime probably does tell us something about objective conditions. I will say that we have a Freedom of Information Act request to the city of Detroit to get the data on property values, so we can actually match that up with the wealth, the subjective wealth ratings. But they just wrote back and asked for so they're going to take more time on that FOIA request. So, but hopefully, eventually, we will have that. Okay. So implications, we've already kind of talked a lot about. We've already kind of touched on most of these. We think in general, it's very tempting to use generative AI tools to do all these things. The idea of silicon sampling is maybe appealing to a lot of people, but we've got to use caution. There's a lot of cautionary tales here. There's a lot of variation depending on how subjective the task is. And we think the more subjective concept that you're trying to get at, the more caution is warranted. In some cases, if you're interested in sort of average, aggregate, overall opinions, generative AI tools might be good enough, right? We get this, 0.8 correlation in some cases, and maybe that's enough for some applications. But we see really systematic biases on dimensions that we might care about, right? Especially when it comes to representing these hard to reach populations. And even where we see strong correlations, when we look at these pairwise t-tests, we see that the bias is often in one direction or the other. So it's not the case that there's just a bunch of noise. If the correlation is 0.8, the rest is just noise. Most of the time, there's actually a bias in one direction or another, which obviously could be worrisome depending on applications. Our prompt engineering, a la silicon sampling, is not a fix. It can even exacerbate the bias. And any talk about generative AI tools has to mention all of these sort of hidden costs of these tools, including these reproducibility issues that we've talked about, reduced transparency, environmental costs. So we think a lot more work needs to be done to sort of understand how to use these tools responsibly. Thank you.
Great, thank you very, very much, Melissa. Without further ado, we'll pass now to Ala's presentation, to Ala's discussion. Ala, I know you have slides. Just give us a sec.
Maybe before I even turn on my mic, before I turn on my mic.
Then I have to turn off. The mic is again on, so.
Yeah, sorry.
No, that's-
Oh, wait. No.
Ah, I'm sorry, I forgot. You kept.
Alignment between.
I think I had a somewhat, I mean, we'll see, we'll talk afterwards. I had a somewhat different reading, but I didn't view it as bias or not bias, but yes. Okay, perfect. All right. So I'm very happy to be discussing this paper. Okay. Oh, I think this is the older version. Sorry, this might be the older version of my slides. Okay, so in terms of the question the paper asks is how do assessments made by generative AI models of subjective images compare with human evaluations? So I didn't really view this as a question of like, is it biased, not biased? It's just like, how does it model human evaluations with the goal of like this silicon sampling idea, right? So like, does it really, because you're not even comparing to like RA's validation exercise. And the focus on subjective images here is because there's no right answer. So it's in a very sense, it's a very difficult test of whether generative AI can mimic human evaluations. In terms of the findings, so generative AI models assess images similarly to a national sample of human evaluators. It just doesn't work very as well for certain subgroups. If you look at by gender or a subnational sample, it doesn't work very well. But what my reading at least is that for the national sample, it's doing a pretty good job. I found this mind-blowing, I have to say. Like, basically, we don't need surveys anymore. Like, this is okay. This is really an exaggeration, and I'll qualify this in a bit. But like, this is quite intense, right? Like, it's a very subjective task. So it's a very difficult test, and we know it's subjective because it doesn't seem to also like neither the surveys. The human samples and GPT don't predict actual events in terms of crime. You look at wealth later, but they don't even predict actual events. So it's clearly subjective task. And yet GPT very strongly correlates with the national sample, right? It is mimicking something real. So the implication here is, okay, don't use GPT or generative AI to mimic a sample of like to do subgroup analysis or mimic a local sample, but you can use it to mimic a national sample, which is pretty crazy. It's mind-blowing. Having said that, I'm going to qualify this now with a few issues from these findings. And I'm going to do this while picking up my laptop because those are the older slides and they don't include some points. Okay, so so there will be some yeah. So there will be some issues with these findings, but basically not being able to track a local sample is not great. I agree with this, but many or most surveys in the US are really national surveys. So it's not like an insane sacrifice. The differences by gender are more problematic, but also they're actually not as bad as I feared they would be, right? Like there are some biases, like when you look at the differences by gender, but they could, I expected them to be much worse than they turned out to be. So what are the issues? There were two other issues that really stood out for me that made me more skeptical and those are potentially the reasons why we shouldn't all just, stop surveying humans and turn to GPT. One is that there's a bit of an issue with the distribution of GPT, which is also somewhat endogenous. So I'll talk about this in a second. And then two, some of the results are actually nonsensical by GPT. So in terms of the distribution, sometimes there are larger differences between like the mean and median for GPT or often there are, and compared to like mean median for the human sample. And you can see most of the standard deviation here for GPT is larger than the sample standard deviation. So the variation there's like a larger variance for the GPT sample than the human sample. So this is one issue. The other thing, though, it seems to maybe depend on the topic. We don't have enough topics here to really finalize this, but with this order, the GPT standard deviation is always larger, and we're talking twice, almost 3 times as large as the sample. But then with wealth, it's actually smaller. Other than this one, the 2 other observations, it seems a bit smaller than the national sample, or than the national sample. So this might be a bit of an issue because maybe the distribution of answers that GPT will give you will vary by topic. And those are all, again, subjective stuff. But if here it varies by topic, then there's something here we really don't understand. Like if the GPT distribution or answers will, even for a subjective or objective question, if it varies by topic, then I'm going to be skeptical. Which topics can I use it for? Which topics can I not use it for? Okay. The other thing is nonsensical results. So what I'm showing you here is sensical. The American, so this is sensible, it makes sense. Okay, so the national sample mean for disorder is 4.51. Women, slightly more likely to say it's disorder, so 4.59. Men is 4.42. So the national sample mean is between men and women. Okay, this makes sense. GPT mean for disorder, when you don't tell it you're a woman or you're a man, is 4.15. But both men and women are more likely to have a higher mean, a higher average score than the national mean without you telling it you're a man or you're a woman. And this is also a problem for wealth. So the overall wealth GPT average is 3.98, but both men and women are more likely to say it's wealthier than the average. So I don't know what to do with this, right? So that's a bit of an issue. It wasn't the case for safety. Safety was more in the middle, but I mean, here it also depends on, like what's the actual average, which we cannot calculate from here, but you're able to calculate it. But this is a bit of an issue. Okay, so going to the bigger question, can generative AI mimic survey responses? Maybe. One issue here is, again, it might be topic dependent because the distribution seems to be better or worse given the topic. And the limitation is not really only by subgroup analysis or like a subnational survey, but it's really for the topic. And the question then I had is, can we identify topics where GPT is good versus, worse at mimicking the population? Then the next thing was the nonsensical results. So should we ask GPT to identify relevant subgroups maybe before defining the main task? So like, give me like the average for men, for women, and the national population or something, as opposed to give me national population, separate request, give me men, separate request, give me women. Okay, my updated slides, which I can only see here, then has like a couple more issues, a couple more questions. So in terms of what's the overall goal of using GPT? Is it to mimic survey responses? Is it the silicon sampling? If that's the goal, then the results are not only problematic because of the subgroups, but even at the national level, it could be context dependent and this topic dependent, and this is another problem. If that's not the goal, then why do this? Like, why are we doing this research? Like, what's the actual question that we're trying to answer here? And then I have another slide, which was very eloquently titled Other Random Thoughts. So other random thoughts I didn't cover here. So first, this is the national level in the US. Would it work well at a national level outside the US? Would it work well at all if it's not English speaking, given the training data set? you have this no memory of previous images. So it's a new request each time. But the national sample, the humans, have this memory, right? Because they each rate in 3 images. So I'm wondering if that's an issue here. Another thing I was wondering about is the temperature parameter. So my understanding is you can vary the temperature parameter to vary, which may make it more or less replicable. But also, this might explain sometimes the higher variance in the chat GPT results. Maybe the temperature parameter is too high. You talk about robustness of the model in terms of the timing where you ask it and the use of Gemini, but then also how robust would it be dependent on the prompt being asked, maybe if you vary the prompt somehow. And then also how robust would it be to like different sample sizes of questions asked to ChatGPT. So now you do like 30 requests per image. Would you have very different results if it was 50 or 100 requests or if it was 10 requests? So it would be interesting to show this as well. Really cool work. Again, I've never said this about a paper I discussed, mind-blowing. So I was genuinely surprised by the results. So really cool.
You are actually, yes, you're more than, you're obliged to respond. Not really, but yeah, you are highly recommended.
Thank you so much for those comments. That was really really great and helpful and thought-provoking. On the nonsensical results, I'm really glad that you brought this up because there was something I forgot to say in the talk. And that is that and this points exactly to the not what you called nonsensical results, when you give the GPT information, even if that information is irrelevant, it over-indexes on that information. So we see both the range and the standard deviation shrink anytime we say, you are a woman, or you are a woman and you live in Detroit. And this is something that I believe is documented elsewhere with these tools. When you give it information, it tries to use that information and then ends up over-indexing. And so that's how we get these not what you call nonsensical results. So I'm glad that you flagged that. I think this is one of what for the proponents of silicon sampling, this is really important, right? Like, it doesn't know what is relevant and what is not relevant. And so the results are going to change, even if they shouldn't actually change. And they might change in the wrong direction, which they do in some cases here. Okay, you gave me a lot. So a few things that I can respond to. National level, outside of the US or non-English speaking, there is work that suggests that these tools just perform a lot worse outside of the US. And they do, like LLMs when it comes to other languages, also the performance is worse. Not always terrible. It depends on the context and the language. But I would definitely expect it to do worse in other settings. In this sense, it's an easier test. On the topic dependent question, so just a little anecdote, when we started this project before ChatGPT was publicly available, and we were purely looking at characteristics of images. We were working with object detection models, and we were interested in like what objective features of images predict people's evaluations of those images. And we asked people questions about, this is along the lines of work by Kara Wong and Jake Bowers and Danny Rubinson and colleagues. We asked questions like, what do you think is the racial or ethnic composition of this neighborhood? We then went to ask the GPT those questions and just flat out refused to answer those questions. In the time that we've been working with these tools, we've sort of like refined questions in a way that we know we'll always get answers, but non-response from the GPT was a big issue when we started the project, and particularly when it came to topics that we were interested in. If there's anything that plausibly related to like race or ethnicity, and there's some other things too, just refuse. I think those were the big ones. I want to leave time for anything else. But thank you, that very helpful comments, and I.
Perfect. Thank you very much. Great. So I'll open it for discussion, and I'll give priority to people who haven't asked the question yet. Starting with Hans Peter.
I mean, what strikes me most is that ChatGPT is more in line with the national evaluations than with the local ones. Did you analyze the relationship between the national and the local evaluations, independently of what ChatGPT says? I mean, if you do that, you could see where the two differ. And that might give you a hint why ChatGPT does better with the national than with the local ones. You might eliminate some local outliers, and maybe then the locals are more in line. But in general, I would study the relationship between the local evaluations and the national ones.
Thank you. We are very interested in doing that. We were imagining that would be the next paper, but we hadn't thought about it as a way of getting at insights into why we see the patterns that we do here. So thank you.
Kevin and then Simon.
Yeah, thanks. This data collection is really cool, and I really like the question. Looking forward to seeing this project develop. I've been fairly skeptical about the use of generative AI to replace human subjects, and I can't help but read. So I think I'm a little bit less taken by the idea that ChatGPT can replace a national sample on this, precisely for the reason I think Ala's comments are very good. If we know it can do it for some topics, then we validated it for those topics. But for the topics we haven't validated for, then we have no reason to believe that it would be particularly good at that. And so it's not even clear to me where we should be confident this can replace anything. So I certainly am just generally quite skeptical of the use of this to replace the subjective evaluations. I thought you did a very good job of walking us through this, and I guess that's my read of your analysis. But would you, in fact, recommend other people continue to use it in this way? Or do you think at a certain point we could say, in fact, this is not a particularly useful tool?
Thank you. That's a great question, and I am in agreement with you. I think I was skeptical of the kind of silicon sampling approach going into this, and this has only reinforced my skepticism for exactly the reason that you mentioned. And I don't think that this is a problem that can be solved by prompt engineering. I think it's pretty clear that it can't be, and I don't see why it would get better with improvement in these models. But the models are a black box, so what do I know?
Yeah, I just had a question/suggestion, which is that have you thought about looking at the outlying cases, meaning, the off-the-line cases where ChatGPT is clearly getting them wrong? And is there something systematic about them? And it goes back in a sense to the first question. Could it be it's just cloudy in those places? Could it be, and then you could understand, then if you took them out, does it do even better? Is there something systematic about the off-the-line things?
Yeah. Yeah, thank you. I think that's a great suggestion. We did a fair amount of piloting with a different random sample of 85 images before we did this. And we did a fair amount of looking at outliers. And actually, one of the things we did was we ran object detection models on the images, which basically just canned object detection models that tell you, there are X number of cars and there's X number of houses and roads and whatever. And we looked at the correlation between that and what we call refusals. So the GPT refusing to answer the question. This was a previous model of the previous version of the GPT that like to refuse to answer the questions. And what we saw was, this isn't directly answering your questions, but what we saw was that often it would refuse to answer images that we sort of thought were more ambiguous. They tended to have more cars or obstructions, or the angle was a little bit more like zoomed out. So we do think that there's a relationship between like what is in the image and the type of image, and an ambiguity, which presumably is also reflected in the variance. Another thing that we did based on the piloting was that we found that there were these areas that were more like industrial or more like highways tended to be more problematic. So if you just take a random, I didn't go into this in detail, but if you just take a random sample of the mapillary images, you're going to get a bunch that are just highways or just industrial areas. And in these places, it doesn't really make sense to ask people, how safe would you feel walking here at night, or in the day, right? Or how wealthy do you think this area is? Like, nobody lives there. So in this iteration, we hopefully cut down on some of that. Well, we did cut down on some of that variance by using the information on land use, like zoning restrictions, and only looking at places that were zoned for residential or commercial use. And then we also did some like exclusion of areas that were within a buffer of highways to try to get at this. So I think there's definitely something to be learned from looking at like outlying cases, or looking to see if there are attributes of images that correlate with more noise or more weirdness. And my sense is that that where there is more noise in the estimates, it tends to be these areas that are less that are more ambiguous in terms of like the land use. Thanks.
Great. Catherine, and then I have Philip, and then Sasa.
I didn't get if you were, so it doesn't perform well when you just asked it. Have you tried, since you have the data with the human, to fine tune it? To see if you can train it to become better? Since you have the data available to do so?
So we haven't yet. This is something that we do plan to do, but at this point we haven't. It's like it's this giant rabbit hole that, like, I mean, it's a rabbit hole we want to go down, but we haven't yet. But yeah, it's a good idea. Thank you. And the literature suggests that should help, at least with LLMs, it tends to help.
Thanks for your fantastic presentation. I would like to make just two very short points. Perhaps I would suggest using 0-10 scale instead of 1-10 scale, because for human subjects, it's very problematic. Many respondents assume that 5 is the middle point on 1-10 scale. And so this can also lead to problems. And then I wanted to ask if the measure of crime is per capita or not, and if not, whether it wouldn't make sense to have it per capita.
Yeah, thank you for that. On the scale, I know that we debated this. I mean, none of us are like survey researcher people, so maybe we made the wrong decision. But the way I would say, like, the way that they have a slider, and the middle of the slider is obviously the middle of the slider, so maybe that helps to, I don't know. Anyway, in the future we can think about doing that. And then your second question, sorry, just went out of my head.
Is the measure of crime per capita?
Oh, per capita, yeah. So no, it's not per capita. And we decided that counts of crime okay. We can't do we can't convert it to per capita using the current. There's a couple different ways we could aggregate the data, right? Right now we're drawing a buffer. We're just drawing a spatial buffer around a point. So we don't have a denominator for that area, right? So we can't do per capita. We can only do counts and just hold the area. There are other ways we could operationalize it. Actually, what we did with, we did this with like 911 calls. It was something I didn't present. We did this when we were piloting. We aggregated to the nearest census block, because there we have, the census block is the lowest level at which people are counted in the US Census. So there you have a denominator and you can calculate a per capita. But the issue with census blocks, right, is that a house might be, I mean, an image might be like in the corner, right? And then you're only capturing everything that's in this quadrant, and you're not capturing like a radius around it. So there are trade-offs, but you know, for robustness, we should do it both ways and see. We thought the buffer seemed more like better at capturing what we wanted to get at, but and also that like Detroit is sort of like the density, the population density doesn't vary a huge amount across the city, so using a count shouldn't be too problematic. But certainly when we scale up, that this would be an important thing to do.
Yeah, thanks. So I had the same question about using training data, but let me phrase it a bit stronger. So I hinted at this earlier. So I think the main reason why we care about this beyond, you know, just being interested in this is because we want to use these models for labeling tasks to save money, right? Or to save money and time. Like it just makes things feasible that otherwise wouldn't be feasible. So I think for me, really the key question is, well, it's interesting as a first step to see, okay, well, it doesn't work without further clarifications or without further refining the prompt or inputting additional data. But arguably, this is also the hardest task you could possibly give to the AI, right? Like it's subjective, but then, you know, you're showing that it's good at the subjective task, but plus you're not satisfied with just performing well on the subjective task. You also want to zoom in on subgroups, right? Like on Detroit, on men, on women, et cetera, et cetera. So this is like, as far as I have seen, this is the hardest labeling task that I've seen GPT models being evaluated on. So given that, okay, so now we know it doesn't work well without further input, fine. But I would like to know, okay, well, how much more do we have to give for it to work better, right? So let's say, like, how many cities would you have to sample for the model to learn and update and then be able to scale to the national level, right? Like, so let's say it were the case that if you did the local sampling in 5 cities, input the data, rerun the thing again, and then it works well, right? Like then it works well for the locally representative sample. That would still be huge, right? Like then still it would allow you to do this thing at a national scale, possibly, or at in similar sized cities, which otherwise you could never do, right? Like without 10 ERCs. So I think, like if I were you, or if I could push you to move in one direction, I would want to know, okay, how much better can it get? And with what kind of data?
Can I abuse my role as chair and
go for it?
Go for a 2-finger on this, because I think it's a very interesting point. I mean, I don't know, maybe it's completely meaningless, but anyway. So the way I think of this is the following: your results are, it works well with national surveys. It doesn't, like, it's nationally representative. GPT, I mean, it's not locally representative. It doesn't give you local averages, right? It doesn't recover local population parameters. So in surveys, no one tells us that they are locally representative. They tell us they're nationally representative. So what do? We do MRP. So a project would be to do MRP for GPT, right? Like try to feed into GPT such information so that it becomes locally representative, the same way as surveys become locally representative. And that's, if you do that, I'm sure that's, a PA or whatever, like MRP GPT, whatever. Sorry, but yeah, it won't respond to SASAs or like. Oh. Mr. P, MRP is post-stratification, multi-level, something post-stratification. So basically, it's a method that Gelman and others have discovered and used extensively to generate representative local samples, subnational samples, driven by the motivation that they would need such samples, especially in the US, at the state level. It's used also in the UK for prediction regions, for forecasting regions, for the election, and so on and so forth. Because all that matters are the seats, and so you want to know locally what they are going to get. And some local surveys, when you do this, you take national surveys and you try to see how they don't perform well. So I had, yes.
Two very short technical questions. The first one is if you tried hyperparameter optimization so that you play around with temperature, the number of examples you give in a prompt, etc. And also related to the fine-tuning discussion we had, if you do that, you can also add batch size, learning rate, and it really significantly improves. We found that it improves way more than changing the prompts, basically. And the second point is, we also know that especially ChatGPT has a lot of trouble with scaling or given a number between 0 and 10, but is way better at scaling things. So if you do these pairwise comparisons and create a sort of scale out of this, whether you maybe get way more reliable results rather than these models given a lot of middle answers because it's just very bad at giving these numbers.
Yeah. Well, okay, so what, so can I mean, these are all, I mean, it's all really good suggestions, and they, I guess what they have in common is they assume that we are like committed to making making this work, to committed to you know, getting, it's all about like getting the GPT to do things better. And I mean, maybe I'm just like tired. This could just be that I'm tired. I guess the usefulness of these, I mean, all of these suggestions are very useful. I think their usefulness does depend on the use case. Like, you know, if city planners want to use this tool to make decisions about how to allocate resources in neighborhoods, maybe MRP isn't going to help them. But if we want to do what we said we would do at the beginning, which is make these, you know, scale these measures of subjective perceptions at scale, then yes, like MRP sounds like it could be promising. And Lauren, I appreciate all of these. Well, you asked me about the like the temperature setting, the hyperparameters. And I'm blanking on what exactly we've done. We have done some, so that you're right, they do matter, and we have done some playing around with them. But I believe like even when we first started, the ability to change those settings didn't exist, and we got similar answers. So this is again one of these things where like the tools change, the tool's a black box, the tool's going to change, and we're going to do all these things, and then it's going to change, and the things that we did might work, or they might not work. So every investment that we make in getting the GPT to do a better job, we have to think about these calculations. And also because our incentives are to publish, right? By the time we get this stuff published, will the technology have moved on? Will everyone have moved on? And I think this is, you know, because I know a lot of the people in this room are PhD students, you know, one thing you need to think about with your work, and especially if you're going to be, you know, using the latest tools and kind of chasing the current hot thing, is that the publication timeline is long for the most part. It can be years until something is published, and this presents these kind of tools that change so quickly, present really big challenges. So not to discourage you from using these tools, but to think carefully about the projects that you pick, and whether like this is something that is still going to be relevant, still going to be useful, still going to be publishable, even if the technology changes in between now and when it's published.
I really don't think there is a better way to close the session than those last final words by Melissa. I think they speak on behalf of all of us. And thank you again very much for coming. Thank you also, many thanks to Ala for coming for the discussion. Thank you all for attending. We're going to go for a very quick aperitivo in Cadi Fagoti as always. And if you want to come, you are more than welcome. Thank you again. And many thanks to CIVICA for making this possible and feasible.
Yeah. Thank you.
Thank you so much.
Thank you.
Davvero, grazie.